estimation for single mean, confidence interval for single mean, and maximum error for single mean. Now let us see the confidence intervals for difference of means. That means when two sample sizes of different sizes are given here, how to estimate the confidence interval for the difference of population means. So as a baseline for a study on the effects of charging electrical pricing for electricity during peak hours was obtained for N1 equal to 45 and N2 equal to 55 hours. Means the first sample size is 45 hours and the second sample size is 55 hours. The usage kilowatt hours is summarized as follows. So size is given, sample mean 204.4 and 130. Now here they have given variance, which is nothing but here sigma 1 square and sigma 2 square. Obtain 95% confidence interval for mu1 minus mu2. So we know that here first we have to write the given data here. So n1 equal to 45, n2 equal to 55, x1 bar is 204.4 and x2 bar is 130. Now sigma 1 square is given as 13825.3 and sigma 2 square is given as 8632. Now for using this data here, we have to calculate the 95% confidence interval for mu1 minus mu2. So the confidence interval for difference of means is given by the formula x1 bar minus x2 bar plus or minus z alpha by 2 into square root of sigma 1 square by n1 plus sigma 2 square by n2 here. Now we asked to obtain the 95% confidence interval, so z alpha by 2 will become here 1.96. So first we have to calculate this z alpha by 2 into square root of sigma 1 square by n1 plus sigma 2 square by n2, which is nothing but the maximum error for difference of means. So z alpha by 2 into square root of sigma 1 square by n1 plus sigma 2 square by n2. So 1.96 into square root of sigma 1 square is 13825.3 by n1 is 45 plus sigma 2 square is here 8632 by n2 means here 55. Now first simplify this square root part here. So 13825.3 divided by 45 plus 8632 divided by 55. So under square root it is 21.5447 into z alpha by 2 is 1.96. So it is 42.276. Okay, now this value we have to subtract and add with the difference of two sample means. That means Ci equal to x1 bar minus x2 bar, that means 204.4 minus 130 plus or minus 42.2276. Sorry, use the round brackets, right? So 204.4 minus 130. It is 74.4. So 74.4 minus 42.2776, it is 2276, comma 74.4 plus 42.2276. So here 74.4 minus 42.2276 is 32.1724 and 74.4 plus 42.2276 is 116.6276. So the confidence interval for the mu1 minus mu2 is here 32.1724 and 116.6276. So sometimes they may give you here standard deviation, that is sigma 1 and sigma 2, then you have to make a square of that. But here we have sigma 1 square and sigma 2 square only. First we have to simplify this part, then you have to subtract and add with this difference of means here. x1 bar minus x2 bar. So for this one bracket and for this entire we have square bracket here. Okay, so this is about the difference of means. Now just now we have seen how to construct construct the confidence interval for the last samples, means when the sample size is greater than 30. But when the sample size is less than or exactly equal to 30, then also we need to construct the confidence interval if the data is here quantitative, means the data which can be measured. So for that, we have to use the students' T tables, and the T table value is mentioned there in the question within a brackets. So if you see the problem here, a random sample of 8 envelopes is taken from the letter box of a post office, and their weights in grams are found to be 10, 10.5, 11.25, 11.5, 11, 11.7, 11 and 11.5. Find a 95% confidence interval for the mean weight of envelopes received at post office here. So first of all, just we have to know what is the sample size. N represents the sample size. So how many observations we have? 8 envelopes. So 1, 2, 3, 4, 5, 6, 7, 8. Right? Then we have to find the mean of these observations and also the sample variance of these observations here. So once again, if you write it here, 10, 10.5, 11.25, 11.5, 11, 11.7, again 11 and 11.5. So we can find the mean by adding all these observations and dividing by the number of observations. And also we can find the variance by making a square of each observation and adding those. So instead of that here, we can use the calci by giving the values in the regression linear mode. That's what we have done in the simple random sample with replacement and without replacement. So let us go to the regression mode and linear and give the values here. So first observation is 10, second observation 10.5, third observation 11.25, fourth observation 11.5, fifth observation 11, sixth observation 11.7, again seventh observation is 11 and eighth observation is 11.5. Now after storing these values here, we have to use shift 1 and we have to find the summation x here. So let this be x, right? So summation x is here 88.45, and also we need the summation x square. So again press shift 1 and press the option 1. So 980.2025. Now we know that the formula for x bar is here summation x by n, right? And that is 88.45 by 8 here. So for that we can use the option shift 2 and first one, that gives the x bar 11.0563. Now for finding the sample variance small s square, here the formula is summation x square by n minus x bar square. That means 980.2025 divided by 8 minus 11.0563 square. Okay, then for this also you can use shift to second option, but you will get the standard deviation. We have to make a square of that. So it is here 0.2846. So small s square is 0.2846. Now here the confidence interval we have to construct 95%. So the 95% confidence interval P alpha by 2 at 8 minus 1 is here 2.37. Okay, now we have to construct the confidence interval. So the formula is here confidence interval equal to x bar plus or minus T alpha by 2 into small s by root n here. Okay, and of course here we have calculated the standard deviation. So that implies small s is nothing but square root of 0.2846. So it is 0.5335. Now substitute in the formula. X bar is here 11.0563. So before that you just calculate T alpha by 2 into small s by root n. So 2.37 into small s is 0.5335 divided by square root of 8 here. So first to simplify this term, so root 8 is 2.8284, then 0.5335 divided by answer you get 0.1886. Now into the table value 2.37 gives you 0.4447 here. Now substitute in the confidence interval formula. X bar is here 11.0563 So 11.0563 minus 0.447, comma 11.0563 plus 0.447. Now simplify this. 11.0563 minus 0.447 is 10.6093 and 11.0563 plus 0.447 is 11.5033. So this is the confidence interval for the envelopes here. So first we have to store the values in the regression linear mode. Then we have to obtain the summation x and summation x square. Now using the shift 2 option, we have to obtain the value of x bar and smallest. Then the table value will be given. Then using the table value, you have to simplify the maximum error T alpha by 2 into smallest by root n. Then add and subtract with x bar. That gives you the confidence interval for single mean when the sample size is less than or equal to 30. Now till now we have discussed about the quantitative data, means the sample size estimation, the maximum error and confidence intervals for the quantitative data when the data is missing. Now there are some cases where we have to discuss with qualitative data also, means the data which cannot be measured in any of the physical units. So for that also we have to just estimate the sample size and also we have to find the maximum error and confidence interval. Now let us move on to the problem on this. What is the size of the sample required to estimate an unknown proportion to within a maximum error of 0.06 with at least 95% confidence? So remember here, for these problems the data will not be measured, but whereas for the quantitative, definitely the physical units, either kilowatt hours or minutes or seconds, like that the data will be measured here. Now here we have to find the sample size between an unknown proportion to within a maximum error of, that means the error is given as here 0.06 and 95% confidence means Z alpha by 2 is 1.96. So when it is given as unknown proportion, then the probability of success and the probability of failure both have the equal chances. That means P equal to 0.5 and Q is also equal to 0.5 since Q equal to 1 minus P. So to estimate the sample size here, we have the formula M equal to Z alpha by 2 into square root of P cube by E whole square. So that means here 1.96 into square root of 0.5 into 0.5 by error is here 0.06 whole square. Now if you simplify this, this is here n equal to, so square root of 0.5 into 0.5 is 0.5 here. So 1.96 into 0.5 divided by 0.06 gives you 16.33. Now we have to make a square of that. So that is nothing but 266.77. Now we have to round off the sample size here. The sample size must be an integer. So m is approximately 267 because here after decimal we have 7. So we have to round off to the next number. So the sample size when we have an unknown proportion of 95% confidence is here 267. Now see one more problem on this. If we can assert with 95% that the maximum error is 0.05 and capital P is 0.2, then find the size of the sample. So here the capital P value is given directly. So we can't take P equal to 0.5 here. So first write down the given data here. So Z alpha by 2 is 95% means 1.96 and error is given as 0.05. Capital P is given as 0.2. So capital Q is nothing but 1 minus P. So 1 minus 0.2 is 0.8. Now we have to find the size of the sample. So again the formula is here Z alpha by 2 into square root of capital P cube by E whole square. Now substitute in the formula here. So 1.96 into square root of 0.2 into 0.8 by the error is 0.05. So this is square. Now first find the square root of 0.2 into 0.8. So it is 0.4. Now 0.4 into 1.96 is 0.784 divided by 0.05, that is 15.68. Now the square of this gives you 245.8. But the sample size should be a number, so approximately 246, because after decimal here we have 8. So whenever the p value is mentioned directly in the problem, then q is nothing but 1 minus p. But whenever the p value is not mentioned, that means both the success and failure has equal chances. So p and q will be equal to 0.5. Now let us see how to construct the confidence intervals for the proportions. In a random sample of 100 packages shipped by air freight, 13 had some damage. Construct a 95% confidence interval for true proportion of damaged package. So here the random sample size is 100. Out of these 100, 13 has damage. That means P equal to here 13 by 100. So the proportion of the damaged packets. So 13 by 100 means 0.13 and Q is nothing but 1 minus P. So 1 minus 0.13 is 0.87. Now we have to construct the 95% confidence interval. So the value is here 1.96. So the confidence interval formula for the proportion is here P plus or minus Z alpha by 2 into square root of PQ by N here. So here also first we have to find the Z alpha by 2 into square root of PQ by N. So Z alpha by 2 into square root of PQ by N means 1.96 into square root of here PQ is 0.13 into 0.87 by the sample size is 100. So first we have to simplify this part, then multiply with 1.96. So it is here. So P is how much here? 0.13 plus or minus. So 0.13 into 0.87 divided by 100 gives you 0.0011. But it is under square root. So the root value is here 0.0336 into 1.96 gives you 0.0659. So that means 0.13 minus 0.0659 comma 0.13 plus 0.0659. Now simplify this here. 0.13 minus 0.0659 is 0.0641 and 0.13 plus 0.0659 is 0.1959. So the confidence interval for the proportion of damaged package is 0.0641 and 0.1959 here. So first we have to find the Z alpha by 2 into square root of PQ by N, which is nothing but the formula for maximum error, and add and subtract with the true proportion, that is capital P. Now let us see one more problem on this. 400 articles from a factory are examined and 3% are found to be defective. Construct a 95% confidence interval. So the sample size is given as here 400 and it is given in the problem directly that 3% are found to be defective. That means P equal to 3% means 0.03. Then Q is 1 minus P. So 1 minus 0.03 is 0.97. Now we have to construct 95%. So Z alpha by 2 is 1.96. So again we have to use the formula P plus or minus Z alpha by 2 into square root of PQ by N here. Now first find out Z alpha by 2 into square root of PQ by N. So 1.96 into square root of 0.03 into 0.97 by the sample size is 400. So this is 0.03 into 0.97 divided by 400 is 0.0001. Now square root of this is 0.0085. So 1.96 into 0.0085 gives you 0.0167. So this is the Z alpha by 2 into square root of PQ by N. Now for the confidence interval, just add and subtract with capital P, that is 0.03. So 0.03 minus 0.0167 comma 0.03 plus 0.0167. So if you simplify this here, 0.03 minus 0.0167 is 0.0133 and 0.03 plus 0.0167 is 0.0467. So this is the confidence interval for the four defective articles here. Now let us see the last problem in estimation. So among 100 fish caught in a lake, 18 were inedible due to the pollution of environment. With what confidence can we assert that error of this estimate is at most 0.065 and the table value is given, that is area value of 1.71 is 0.4564 using normal tables. So here we have to find with what confidence means we have to find the value of alpha here. So first write down the given data, that is n equal to 100. Now among these 100 fishes, 18 were inedible. So we have to find the proportion of inedible. So this is P equal to 18 by 100. So 0.18. Okay. Then Q represents the proportion of edible. So P represents the proportion of inedible and Q represents the proportion of edible. So 1 minus P, that is 1 minus 0.18 gives you here 0.82. Right? Then with what confidence can we assert that the error of this estimate is at most 0.065. So error is here 0.065. Now we have to find the alpha value here. So the formula is here Z alpha by 2 is equal to, actually the formula is error equal to Z alpha by 2 into square root of PQ by N here. But here Z alpha by 2 we have to find. So E into square root of N by square root of PQ here. Okay. So now from this here, E means here 0.065 into square root of the sample size is 100 by square root of PQ means 0.18 into 0.82 here. So we know that square root of 100 is 10. So first you find out the square root of 0.18 into 0.82. So into 0.82 gives you 0.1476. Now square root of this is 0.3842. Now coming to the numerator here, 0.065 into 10 is 0.65 here. So this is nothing but 0.65 divided by 0.3842 gives you 1.6912. So 0.18 into 0.82 is here 0.38. Now 0.065 into square root of 100 is nothing but 0.65. Now simplify this 0.65 by 0.38, it is 1.71. So that means Z alpha by 2 is 1.71. Now the Z value is here. That means the ordinate of 1.71 is 0.4564. Now from this here, alpha equal to 0.4564 into 2. So that is nothing but here 0.9128. But always we measure the confidence in terms of 100%. So it is 91.28%, which is nothing but 91%. So with what confidence we can assert means with 91% confidence we can assert that the estimate is at most 0.065. So with this we have completed the problems on estimation. In the next class we will continue the problems on estimation using normal distribution.